Hi everyone, we are talking about exponential functions and their derivatives. This is what we already know, hopefully. Hopefully this is what we already know. A logarithm can be rewritten in terms of an exponent, okay, so including natural log. So a logarithm really is just an exponent. Okay, it's another way of writing an exponent. Or it's our inverse function. Okay, so first thing they want us to do is solve a couple exponential functions. So let's go ahead with that. So the opposite of e to the whatever is natural log. So we could natural log both sides. Or you could think about this as just rewriting it in logarithmic form. So converting between these two forms right here. So I get x plus 1 equals natural log of 7. So x equals natural log of 7 minus 1. Okay, and if we did this in our calculator, because they want us to give decimal answers, it would be 0.945. Okay, kind of the opposite thing here. I have natural log, and I want to rewrite this in exponential form. So, we do the big E, so we introduce a base E that cancels the natural log. But what we're really doing is rewriting this in exponential form using kind of a shortcut. So I get x equals e to the 5th plus 3 all over 2. And they want us to evaluate this to 3 decimal places, so 75.706 is what I got. Okay, the derivative of the exponential function is arguably the easiest one. It's just the derivative of e to the x is just e to the x. The derivative of e to the u is e to the u, and then times du dx, or we could write this as e to the u times u prime. So all you have to do is remember chain rule. Do not get this confused with power rule, which is x to the n. Okay, these are not the same thing. Notice how, in this case, x is my big number, it's my base. Okay, not my exponent, it's my base. Here, x could be my exponent, it's not my base. My base is a constant here. Do not get these confused. Okay, this is not power rule that we're doing. This is a whole different function. That's only for polynomials and such. This is for exponential functions. Okay, so really easy. You just literally rewrite what you're given and then do chain rule. Okay, so I want to find y prime. Y is equal to e to the 3x squared. So I literally just rewrite e to the 3x squared times the derivative of my exponent, so 6x. Okay, I'm going to rewrite this one. So I have sine of e to the x squared, just so I see. I really have 3 layers here. Okay, I have the squared, I have the sine, and I have the e to the x. So y prime is 2 sine of e to the x times cosine of e to the x times the derivative of e to the x is just e to the x. Okay, so we had 3 layers and we got 3 parts to our problem here. Okay, I want to find y prime. So first I have to take the derivative of my natural log, okay, which we've done before. So all we got to do is big bar, okay, I take the bottom, I write it right here, okay, and then I take the derivative and put it on top. So the derivative of 4 is 0, the derivative of e to the 3x is e to the 3x times 3. Okay, so remember, you rewrite it and then you do chain rule. Okay. Now here, something that looks a little more complicated, but it's really not. So y prime is equal to, remember, we do our division, so I just rewrite what's on the bottom here. Okay, so the derivative of natural log, we rewrite the bottom, and then I take the derivative of the inside on top. So the derivative of e to the x cubed is e to the x cubed times, now I look at the exponent, the derivative of x cubed is 3x squared. Okay, so take this step by step. Okay, so first thing, derivative of natural log. Make your fraction, put the inside of your natural log on bottom, take the derivative on top. Derivative of e to the x cubed. Well, you rewrite e to the x cubed, then you take the derivative of your exponent, which is 3x squared. Okay, so just take it step by step, don't rush it. And hopefully you don't make mistakes. Okay, we have a rational function inside of our natural log this time, so a little more complicated, but we can make our lives easier by using our log rules. Oops. sorry, that's going to be a minus natural log of 3 minus x. Don't know what I'm doing. E to the x. Okay, now we can take our derivative. It's going to be much easier for us. Alright, so derivative of natural log. Make your bar 3 plus e to the x on bottom, derivative on top, which is just going to be e to the x, minus, make your bar 3 minus e to the x on bottom. The derivative of 3 is 0. The derivative of negative e to the x is negative e to the x. And, you could combine these negatives here if you wanted to. And could you combine these terms again? Sure you could. Do you have to? No, I don't know why you would. All right, and next one. We have a product, so let's do product rule. Derivative of x squared is 2x. The derivative of e to the negative x is, so again, we rewrite it, and then we multiply by the derivative of our exponent, which is negative 1. Okay. All right, next page. Now we want to use implicit differentiation to find dy dx. Okay. Let's differentiate. So we have to take the derivative of everything. Now this one's going to be a little weird because I have a product inside of my exponent. So the derivative of e to the xy is e to the xy. Okay, so remember, you're always going to rewrite it. Now I take the derivative of my exponent. So the derivative of xy is y plus x dy dx. Okay, so we had to do product rule there. Plus 2x minus 2y dy dx. And that's equal to 0. All right, looking good so far. I think I can take some stuff out. So I want to get this dy dx by itself. So what I'm going to do is distribute my e to the xy to both of these. So I have y e to the xy plus x e to the xy dy dx plus 2x minus 2y dy dx. Okay, and again, this and this is what I want to isolate. So I'm going to go ahead and factor out a dy dx out of both of those. Okay. And I'm going to move everything else to the other side of the equal sign. So I'm going to move this term and this term to the other side of the equal sign. Okay, and now I can isolate dy dx by dividing. Okay, and that is our answer. Okay, now they want us to find relative extrema points of inflection and sketch the graph of our given function. Oh boy. Well, to find our extrema, we need to find our first derivative. I have a product of two functions, so I'm going to do product rule. Okay, so there's my product rule. You can check your work. You can check my work, and I'm going to go ahead and factor out this e to the x just to make my life a little easier. It looks a little simpler that way. Okay. Now, I need to find my critical numbers. Okay, so for my relative extrema, which is the first thing I'm going to do. So this is the first thing I'm going to do, second thing I'm going to do, third thing. Okay, so for the first thing I'm going to do, I'm going to find my relative extrema. And so that's where this is equal to 0. I see that x equals -1 is going to be a critical number because e to the x is always going to be positive. So I'm going to make a line chart. And let's test. Well, any number smaller than -1 is going to be negative. So that's kind of obvious. Any number bigger than -1 is going to be positive. Because again, any number you plug in here is going to be positive. So I'm really only testing this. So I see that I have a relative minimum at x equals -1. Okay, second part. I want to find points of inflection, so I have to take the derivative once more. So f double prime of x. So you could do product rule here, or you could just take the derivative of this. I'm going to take the derivative at this stage because I think it's a little easier. So e to the x plus, well, I actually already took the derivative of x e to the x. It's e to the x plus x e to the x. Look at that. So this is the same thing as 2 e to the x plus x e to the x. Factor out an e to the x, we get 2 plus x right there. Okay, so I think a potential point of inflection will be at x equals -2. Let's test it. So anything to the left of -2 is going to be negative. Anything to the right is going to be positive. It does indeed change sign, so I do have a point of inflection at x equals -2. All right, let's get your graph. So a little weird. The points that I have to work with are -2 and -1. Okay, so let's think about this. You know what? Maybe we make a line chart. So the points I'm working with are -2 and -1. So anything to the left of -1, I'll do my first derivative on top, second derivative on bottom. Anything to the left of -1 is going to be negative and then positive. For my second derivative, same thing, except at -2. So negative, positive, positive. Okay, so this tells me that I'm decreasing and I'm concave down. So I'm decreasing and I'm concave down at -2. Sorry, until -2. And then once I hit -2, I'm concave, oops. When I hit -2, I'm concave up, but I'm still decreasing. And then when I hit -1, I'm still concave up, but now I'm increasing. Okay, so that's all that information that I got from there. Okay, that's it for this video. I will see you all later.